This is a thick-shelled river mussel, or Unio crassus in Latin. It is one of the most rare and threatened species of mussel in Europe. This is because many of the watercourses where the mussel once lived have been destroyed by pollution and drainage. The County Board of Skåne are restoring habitats and trying to reintroduce the mussel to some of the rivers where it once lived. This also favours many other species, improves the water quality and reduces the amount of nutrients that reach the sea. But no one has ever tried reintroducing the thick-shelled river mussel before, so the question is, will it work? All living things require water. Water is in constant motion, changing form in its eternal cycle. Water creates life both under and above the surface along its journey. Lots of species are dependent upon the habitats that the water creates. Rivers, streams, wetlands, lakes, ponds, and the sea. Water flowed freely through the landscape for a long time, but in the middle of the 1800s there was a major food shortage in Sweden. In order to gain more land for cultivation, wetlands began to be drained. Streams and rivers were deepened and straightened. The drainage of arable land has massively improved opportunities for growing crops and is a key element of modern farming. But the drainage of the landscape has also had a cost. Many of the species that thrive in the meandering streams or wetlands have significantly reduced or completely disappeared. Wetlands, which are nature's own treatment plants and which, for example, take up excess nutrients from arable fields, have in some parts of the country reduced by 90%. Even the mussels, which also work like treatment plants because they filter the water on its way to the sea, have virtually disappeared. Instead, the nutrients end up in the sea, where they cause eutrophication, algal blooms, oxygen depletion, and death of the animals and plants on the seabed. In this LIFE project, called the Thick-Shelled River Mussel Brings Life Back to Rivers, government agencies and researchers work closely with landowners, and a major objective is to get the thick-shelled river mussel back into some of the rivers they once inhabited. One of the sites is the Fyleån stream in Skåne. The stream and the valley, owned by Högesta and Rödingeberg estates, will be restored, which means that it will regain its original meandering route. The new stream bed will also allow the surrounding land to flood more easily. This creates wetlands where many plants and birds thrive, including the mussel. It is a large project. The project is also breeding mussels in a laboratory with the aim of reintroducing young mussels into the restored stream bed in the Fyleån River. But this is the first time that we have tried to breed thick-shelled river mussel artificially, so there are many uncertainties. Lea Schneider at Karlstad University is working on the breeding programme and to increase our knowledge regarding the ecology of the thick-shelled river mussel. The mussel has a complex life cycle. In the spring, the females release millions of larvae into the water. A few of the larvae attach themselves to the gills of a fish in the river. This fish becomes a host and the mussel larvae a parasite. The larvae then grow and feed for about a month on the fish gills. Then they are called glaucidia larvae and begin to take on the form of a mussel. When they are about 500 microns, they let go of the fish gills and fall down onto the riverbed, where they stay for a few years. but researchers are still unclear about which fish species act as hosts for the mussel larvae. In order to find out, Leah and her colleagues are studying fish in several of the rivers where the thick-shelled river mussel is present. They catch the fish and then study the gills using a microscope and count the number of Glaucidia larvae of different species. Interestingly, it seems that the thick-shelled river mussel uses different fish species in different rivers, but the most important host fish are common minnow, bullhead, bleak and three-spined stickleback. The next challenge is to breed the mussels in the laboratory. This has never been done before in Sweden. Pregnant mussels are collected from a nearby river. They are often deeply buried in the riverbed and not easy to find. But Leah and her colleagues are experienced. They carefully take the mussels out of the riverbed. A few pregnant females are then transported to the laboratory where they are put into aquaria. The hope is that they will release their larvae in the aquaria and that these larvae will then attach themselves to the gills on the bullhead fish that the researchers have collected from the Fyleån stream. The pregnant female mussels normally release their larvae when the water temperature rises above 10 degrees. The researchers raise the temperature slowly in the aquaria. Will any of the females release their larvae? At the same time as Leah is carrying out her research, work to reshape the Fyleån stream is ongoing. Diggers occupy the valley and dumper trucks shuttle back and forth. Slowly but surely the new stream takes shape. The last time the Fyleån stream was dug out was in 1865. The aim at that time was to straighten and deepen the stream. When the material from the bottom of the stream was removed, the thick-shelled river mussel disappeared from Fyleån. Now the opposite is being done. The stream has regained its meandering route through the valley. The new riverbed is shallower and new material is being laid down to favour the thick-shelled river mussel. The old straight ditch is filled in. Life returns to the Fyleån stream. One night it happened. The females began to release their larvae into the aquaria. One after the other they release their larvae, and soon the aquaria are filled with thick-shelled river mussel larvae. Now we need to hurry. As soon as possible the larvae need to be put into the aquaria with the bullheads from the Fyleån stream. But will they really attach to the gills of the bullhead fish? Will it work? After a few days the result is checked in the microscope. Success! The bullheads in the aquaria have got thick-shelled river mussel larvae attached to their gills. After they have grown for a month, the mussels let go of the bullhead's gills and they are collected up in a specially built container. The mussels are ready to be released. After 2 months of digging, the new stream bed is finished. The small mussels are reintroduced into the Fyleån stream. They are put in boxes with a certain number of mussels in each box. This is so the researchers can study the survival and growth rates of the mussels in the years to come. It will only be after a few years that we will find out if the efforts to reintroduce the thick-shelled river mussel to the Fyleån stream have been successful. We will, however, have dramatically improved the level of knowledge about the thick-shelled river mussel, and a unique breeding method has been developed, which has, for the first time, made it possible to reintroduce the species to rivers from where the mussels had disappeared. The project has also created new habitats for many more species. 1 year after the restoration work, the fish sampling gave surprisingly good results. The ditch, which was once virtually devoid of fish, now teemed with life. In the newly restored stream, no fewer than 5 fish species were caught, of which 4 can be host to the thick-shelled river mussel. The project has also improved the water quality in the Fyleån stream. Nutrients from the surrounding arable fields are now being taken up to a much greater extent instead of ending up in the Baltic Sea where they lead to eutrophication. The project in the Fyleån stream shows that it is entirely possible, by working together with landowners, government agencies and researchers, to implement a project which favours people, animals and nature, both on land and in the sea. The hope is that the experience from the Fyleån stream may act like ripples on the water and contribute to other projects being carried out in the same spirit. The well-being of future generations depends on it.